to the stoichiometry questions that I gave you. Now, those 10 questions would be common question 4 style, short questions, for you to practice on the chapters that we've done. So the first question was to find the empirical formula of epoxyethene. So empirical formula, gives the simplest whole number ratio of the elements that are present in the compound. So they told you that there was carbon, hydrogen, and oxygen present in the compound, and they gave you the percentages as well. So remember the steps. Your first step all of the time is to calculate number of moles. So that's what I'm going to do now. So we're going to divide this by 12 because the AR for carbon is 12. We're going to divide the 9.1 by 1 because the AR for hydrogen is 1. And we'll divide the 36.4 by 16, okay? And when you do that, then you're going to get 4.54, 9.1 obviously, and 2.275. Now, how do we come to try and get the simplest ratio? Then we pick the smaller number and we divide them all by the smaller number. So the smallest number is 2.275, so that's going to give us 1. When you divide this by 2.275, you get 4, and divide that by 2.275, you get 2. So that's our ratio now. So when you're writing, don't forget to write the empirical formula afterwards at the end too as your answer. So your answer is C2H4O. Okay, question 2 then. It asks you to state Avogadro's law. That comes up a lot. Avogadro's law states that equal volumes of gases, okay, so equal volumes of gases will contain equal numbers molecules, okay, under the same conditions of temperature and pressure. Because if you change the temperature or the pressure, then you're going to change the volume. So equal volumes of gases contain equal numbers of molecules under the same conditions of temperature and pressure. So I hope everyone's learning their definitions. Now, question 3 then, it said calculate the mass of sodium chloride that you would need. So say if you were asked to make a 0.9% weight per volume, remember? So this is grams in cubic centimeters. And because it's 100%, it's grams in 100 cubic centimeters. Remember that? Now, they want to make 500. So 0.9 grams in 100 cubic centimeters. So if you needed 500 cubic centimeters, what mass of sodium chloride would you require? Multiply by 5. So your answer is 4.5 grams. Okay? So the mass is 4.5 grams. So just bring it up to 500. Question 4 then. Now, they showed you quite a complicated looking structure there, okay? So the first thing that you notice is the benzene ring, okay? Now, remember that benzene is C6H6, okay? Just let me finish this off there for a second. Double bond O and a H. Now, benzene is C6H6, but remember, for this carbon atom to be able to attach onto the benzene ring, you have to lose one of the hydrogens. So it's actually C6H5. Remember, we were doing that when we were using the models to represent the benzene and that. Now, how many other carbons have I got? 1, 2, 3. So I have 3 more carbons. Okay, I have how many more hydrogens? So I have 1, 2, 3 more hydrogens, don't I? And I also have an oxygen. All right, so I have another oxygen. So when you add that up, then it's C9H8O. And when you work out the MR of C9, so add it up and show the workings out. So you'd have 9 by 12, you'd have 8 by 1, and you just have the 116. So when you do all of that, you get 132 grams. So that's the MR. Now they're asking you for percentage, how many moles in 1.65 grams of that. So if your formula for that, to calculate number of moles, okay, number of moles, they're giving you the information in grams, so it's going to be mass all over the MR, so it's 1.65 all over. We worked out 132 there for the MR, so your number of moles works out at 125 moles. Okay, so that's question 4. Now, with question 5, they asked you then to confirm the presence of sulfite ions, so you know your test for anions. Now, question 5 then, you were asked there about copper. So it says copper reacted with nitrogen, okay, and you form copper nitride, IDE, all right? Now, they're giving you the grams. So they have 19.05 grams of copper. They're not telling you how much nitrogen, but they are telling you that they made 20.45 grams of copper nitride. So by subtraction, you're going to get 1.4 grams there. Because remember, conservation of mass, that the mass of the reactants, which is your copper and your nitrogen, have to equal the mass of the product, which is copper nitrate. Now you're asked to calculate the empirical formula. So you're going to use the same steps as I used in the very first question. So this time you're given grams, so that. Now divide by the AR of copper, which is 63.5. The AR of nitrogen is 14. When you do that, then you're getting 0.3 and you're getting 0.1. The smaller number is 0.1, so divide both by 0.1 and you'll get 3 and you'll get 1. So just run over the steps there now again from empirical formula. So whatever the quantity is, be either percentage or grams, doesn't matter, get moles. First step, get moles by dividing by the AR. Once you have moles, then you need to get the simplest whole number ratio. And how you do that is you divide by the smaller number. So our ratio here is 3:1. And don't forget to write, the actual formula out at the end. So it'll be Cu3 and N, copper nitride. Okay? Now, the definition of a mole, everybody knows the definition of a mole. Now, again, same thing, question 7 is empirical formula, but this time it's sulfur and oxygen. They're telling you 40% sulfur, 60% oxygen. So do your, divide that by 32, this by 16. When you divide that by 32, you're getting 1.25. 3.75, the smaller number is clearly 1.25, so divide both of them by that and you're getting 1:3. And then don't forget to write down the empirical formula at the end, SO3, okay? This question 8 is going to be similar to what we'll be revising in, for your titration, the washing soda titration, which was the last titration that we did. So magnesium sulfate, anhydrous and water. So this is the hydrated form because the water is attached. Okay, so there you're hydrated, and then this is the anhydrous, no water. The water has been burnt off, if you like. Okay, now they told you that you have 4.1 grams of this and 2 grams of the anhydrous. They didn't tell you in the question how much water, but by subtraction you're going to get the water there to be 2.1 grams, and then same idea. Okay, so divide this by the MR of magnesium sulfate, which is 120. Water, is 18. You're getting number of moles, okay? So this is 0.167 moles. This is 0.1167, which is the smaller number, this one clearly. So divide by the smaller number. So you're going to get 1:7 when you do that. And then, like I said previously, don't forget to fill in the 7 into the X, in the formula up here. And that will be your answer as such at the end then, the magnesium sulfate 7 waters. Now, question 9 then, it told you that 21.5 cubic centimetres of ethanol was in a can of beer which contained 500 cubic centimetres of beer. So always write down the information kind of in shorthand from the question. Pull out what they're telling you. So 21.5 cubic centimetres of ethanol in 500. They want you to calculate the percentage in V by V. So what's V by V again? So many cubic centimetres in 100 cubic centimetres. Always in 100, okay? But this is in 500, so you'll divide by 5. Both sides by 5. So divide that side by 5 and that side divide by 5. So when you do that, what do you get again? Let me see. So divide that by 5 and you get 4.3 cubic centimetres in 100 cubic centimetres, okay? And then finally, you're asked to calculate, or just maybe rewrite that then as percent, the way you were asked, V, that's a V by V. Okay. Finally, then you're asked to calculate the percent. Now, methyl benzene. Now, that looks straightforward enough when you look at it first, but then you realise, oh, hang on a second, I have to calculate the MR of methyl benzene. So, do you remember what methyl benzene looks like? Okay, methyl, CH3, and the benzene ring. But watch the benzene ring, C6H5, because one of the hydrogens has to be knocked off, and you're adding on that. So it's a C, 7H8, okay? And when you work out the MR of that then, you're getting 92 for that, okay? So 92 is the MR of the methyl benzene. Now, you're asked to calculate the percentage carbon. Now, there's quite a lot of carbon. Look, there's 7 carbons, 7 12s. Each carbon is 12, is 84. Divide that by 92 and change the percent by multiplying by 100 over 1. And you're getting 91.3% then as your answer. Okay, thank you.